Hey guys, I'm going to go through 5.5, which will be solving exponential and logarithmic equations. Alright, so trying to solve for values of x in these equations, we have log with some base of 1 over 32 is equal to 5. So I'm not sure if you guys remember, we talked about how logs equal exponents. So how am I going to evaluate or solve for this value of x right here? So if we think about how to convert logarithms to exponentials, or thinking about how logs equal exponents, we can look at it like this right here, where we think about the base. So the base, if we're thinking about converting this to an exponential form, the bases have to be the same, so x, and logarithms equal exponents. So this 5 represents the exponent of this variable x, and this should equal 1 over 32. So I'm just rewriting this logarithm as an exponential expression to help me kind of see what I need to do here. So rewriting it as x to the 5th equal to 1 over 32. Now I have a kind of a clearer direction on how I can solve for x right here. What I can do is on both sides I can take the 5th root. So I'm going to take the 5th root of both sides. So whenever I do that to the left side, it becomes x. When I do that to the right side, I get the 5th root of 1 over 32. And if anyone remembers their properties of radicals and of all that right there, this will just be equal to 1 over 2. So I can just think about this as the 5th root of 1, which is 1, and the 5th root of 32, which is 2. So 1/2 will have to be this value of x right there. So yeah, there you go. Okay, I've got another one, solve for x. However, x this time around, x is right here. It's not the base, but we can still use the same technique that we did before, just write this as an exponential. So in this case, it would be 10, and logs equal exponents. So using the base 10, the exponent is equal to -1, and this should equal x. So this is actually really quite nice right here, because now I can just think about this like I already have my answer. X is equal to 10 to the -1, except we're not supposed to use negative exponents. And if you remember properties of exponents, negative exponents just mean reciprocals. So 10 to the -1 just means 1 over 10. Yeah, there you go. So 1/10 would be the solution here. Okay. All right, now here, you can keep doing that same kind of technique. However, I'm going to introduce an alternate technique, and that is doing what we call exponentiating with a base. So there's an operation we're going to call this exponentiate. Exponentiate with a base. So this is a process. Well, we've solved equations like, for example, we've solved equations like x squared is equal to 100. And we do this process on each side. What we'll do in order to get x by itself, what we'll do is we'll take the square root of both sides. So the operation that we're doing is called the square root, right? And that's how we undo some values right here. So how do I undo a logarithm? We can do this operation, and the operation is called exponentiate. So exponentiate means to give something a base. To give a value, I guess I'll say to give a value or variable a base. So for example here, one thing to note that for logarithms, b to a log, so b, if this is a base, if it has an exponent with a log of base b of x, well, this is going to be equal to x right here. So essentially what happens is that the base and the log base b, they cancel out. They become 1. And we're just going to be left with x. Okay, and you can also, well, maybe we'll go over that in just a little bit, but yeah, this is what it means to exponentiate. So to give something a base. Now, looking right here with a log base 2 of 3x minus 2, our objective is to solve for x. We're trying to get x by itself, but this x is located within this logarithm. How do I get rid of this logarithm? What we're going to do is exponentiate the left side. So we're going to exponentiate, meaning that we're going to make this a base 2 and make this the exponent. So we're giving this a base 2 and we're allowing this part to become the exponent. But we have to do the same thing to the right side as we do to the left side. So we're going to exponentiate the right side as well with a base of 2, with the same base. So that's going to cancel out with the exponential with a base of 2 and a log base 2 are going to cancel out, leaving me with 3x minus 2, and then that's going to leave me on the right side with 2 to the 4th. Okay, and then we'll have 3x minus 2 equal to 16. And look, now I just have a linear equation. I can solve for x much easier this time around. So I can subtract 2, subtract 2. I'll get 3x is equal to 14. Right, 2 to the 4th. 2 to the 4th. Something feels a little off right here. Hold on, let me look at this. Let me double check because I divide by 3. Oh, that's because I shouldn't be subtracting 2. I should be adding 2. There we go. So then that will make this 18. So 18, and then I'll divide both sides by 3, divide by 3. So then I'll get x is equal to 6. So that will be my solution for this x right there to make this equation true. All right, let's try that with 4. So for question 4, we have a log base 4 of negative 2x plus 4. Let's get rid of this logarithm. So on the left side, we're going to exponentiate it with the base of 4, but we're also going to do that to the right side. So this is going to cancel. We're going to get negative 2x plus 4 is equal to 4 squared. 4 squared is 16, so negative 2x plus 4 is equal to 16. And now we have a linear expression. I can solve for x. So subtract 4, subtract 4. We're going to get negative 2x is equal to, it's going to be equal to 12. Divide by negative 2, divide by negative 2. And we're going to get x is equal to negative 6. There you go. All right, moving along. So for question 5, very similar. The only thing I want to do first here, so I have this logarithm, I want to get rid of it, but I can't exponentiate because I have this coefficient right here. So I can do one of two things with this coefficient. If you remember your properties of logarithms, you can move that up here, or you can actually just divide it out. So I'm going to choose to do that one right there. So I'm going to divide out the 2. So divide both sides by 2. That's going to give me a log base 3 of x plus 28 equal to 3. Now I'm going to choose to exponentiate both sides with a base of 3. So that's going to give me x plus 28 equal to 27. Then I'm going to subtract 28 and subtract 28. So then I'm going to get x is equal to 1. Now, I probably should take a little bit of a pause here and mention that as you solve logarithms, I probably should have mentioned this like probably when we got to question 3. So whenever you solve logarithms, logarithms have a very similar characteristic to square root function. So let me actually just graph this for visual purposes. So if you guys remember square root functions, so square root of x is a function that the domain is x is greater than or equal to 0. So trying to keep that in mind, if I were to graph just any regular log, so I'm going to do a log of x, just basic log of x. For log of x, this is also similar that the function is greater than 0, only greater than for log. So basically, you can't use negative numbers in logarithms. So if you get a negative number as your answer, or if you try to input a number if you try to input a negative number in here into a logarithm, not for x, if you try to input a negative number for a logarithm, you're going to have no solution, actually. You can't plug negative numbers into logarithms, okay, because that's not part of their domain. Negative numbers aren't in the domain of logarithms. And so if you are having struggles with questions that's saying it's wrong, maybe see that if you take the number that you get and you plug it in, so say if I take 6, let's say, for example, I got -6 for this question. If I plug in -6 right here, if I do plug in -6, that would become -20 overall, but I can't use -20 in a log base 2. So that would mean that my answer would be no solution. So keep in mind that you can have no solution here. So for question 4, why is it okay that this x is negative? Well, if you plug it in, actually, it's okay if x is negative. You just can't have the logarithm number be negative. So if I plug in this negative right here, that's -2 times -6, which becomes +12 plus 4. So overall, this becomes 16. And so this is okay. It's okay if x is negative, but not for the value of the logarithm to be negative. So just keep that in mind. So this becomes -1 right here. So as long as you can plug it in right here and still get a positive number, you're okay. So I'm not sure if anyone struggled with that or if they've had a problem with no solution here, but hopefully you guys have gotten further into this to hear that. All right, for question 6. All right, so I want to solve for x. I want to get rid of the log, but I'm first going to deal with this 5 right here. So I'm going to add 5 to both sides. All right, so then that's going to give me a log base 2 of x plus 8 equal to 4. Then we're going to exponentiate both sides. So then we're going to have x plus 8 equal to 16. Because 2 to the 4th is 16, we're going to subtract 8 and subtract 8. And we're going to get x is equal to +8. Okay. All right, for this one, we're probably going to have decimal answers. So we are using natural logs, so we'll need a calculator here. So I'm going to start by subtracting 4 from both sides. So I'll get the natural log of x plus 2 equal to 3. And now I'm going to exponentiate. But what do I exponentiate with a natural logarithm? You're supposed to exponentiate with the same value of the base. And the base of a natural logarithm is e. So I'm going to exponentiate both sides with that same base, with a base e. So on the left side, those cancel. And I'm going to get x plus 2 equal to e to the 3rd. And then I'm going to subtract 2 from both sides. So notice how I'm just keeping e to the 3rd as e to the 3rd. So I'll get x is equal to e to the 3rd minus 2. That's the answer. But we do want to input this answer as a decimal. So if you have decimals or if you have a calculator, let's just go ahead and go in here and type in e raised to the 3rd and then minus 2. So I get 18.09, rounding to the hundredths. So x is equal to 18.09. That's